50 years after the Apollo missions, the lunar surface has new visitors. A major event. Fresh space exploration to revolutionize our knowledge. January 2019, a Chinese probe lands on the far side of the moon. An historic moment, a scientific feat that focuses all attention on the moon. But what is the purpose of such a trip? To extend lunar science? To better assess its resources and exploit them? To set up inhabited bases before going on to Mars? Or even further into space? To find out what's at stake, we're off on a global survey. For the first time, the pioneers of the Chinese space program have agreed to take us behind the scenes of this unusual adventure. This fires the enthusiasm of researchers all over the world. Their ingenuity is mobilized to unlock the secrets of the moon and beyond of the entire solar system. A new celestial cartography is emerging, revealing unknown territories and resources of inestimable scientific value. We're experiencing a real space revolution, a revolution that begins on the far side of the moon. French astrophysicist Christophe Galfard caught the space bug as a child and now devotes his life to deciphering the mysteries of the universe. Today, he's going to meet scientists from all over the world to question the new space era that is coming. For the first time, the China National Space Administration, CNSA, opens its doors to us. Their researchers tell us about their progress and the incredible challenges of this scientific quest. Like all nations that venture into space, China experienced teething troubles. But today has worked its way up to the level of the best in the field, and has shown as much by methodically achieving all its space firsts in record time. Beijing, the capital, is home to the major research centers that have enabled this meteoric progress. The probes of the Chang'e program are designed at the Academy of Space Technology under the direction of Chang'e. She is now shouldering the most ambitious exploration project since Apollo.
我差不多从01年开始，从嫦娥1的论证开始哈，20多年在这个深空领域。我们做月球探测的研究，当然是希望能够到达月球上尽量多的地方，能够获得更多的这个科学探测的数据。如果去背面探测，应该可以获得更多的科学上的新的发现，技术上的一些进步。所以，如果能去背面，肯定是更好的一个选择哈。所以当时我们也是在评估我们的技术能力的情况下，觉得我们具备这样一个能力，所以选择让嫦娥4着陆到月球的背面去。
For Chang'e and her teams, trying to reach the far side of the moon became an essential challenge after the success of the first probes placed in orbit or landed on the visible side of the moon. Until now, no space agency has ventured to the far side because it's inaccessible to our means of observation and communication. It's impossible to land there without a relay satellite. To solve this complex problem, Chinese scientists have developed a special type of satellite and determined the precise point in space to position it.
相对来说，它就是始终看着这个月球背面和地球，同时可以看到啊。所以这一点呢，就是可以实现全实时，就是不间断。就是中继这个任务呢，同样是虽然技术可能是相对比较成熟的，但是毕竟在任务中串联了一个这个关键的环节啊。如果这个环节出问题，那这个整个任务也就无法实现了。
The relay satellite, named Kukiao, was implemented by the Sansichu team with perfect reliability. This, too, is a first. The Chang'e 4 probe, surmounted by its rover, could head for the far side aboard the heavy launcher Long March 3B. January 3rd, 2019, a crucial step in this unprecedented exploit. Landing out of sight of the Earth in a totally unexplored area. Chang'e and her teams are holding their breath.
当时着陆那天，因为着陆过程，我们有这个降落相机的一些图像会下来，我们能够看到一帧一帧图像，我们就离月球越来越近了。当时像北址那个大厅里，大家非常非常安静哈，还是比较紧张的。然后终于最后我们能够看到那张照片，就是我们相机冲下嘛哈。就着陆器下方只是一些星壤飞扬，着陆器不动了，我们星上的遥测参数都是对了，就是安全着陆了。当时还是很激动、很欣喜吧那种。
嫦娥4号呢，确实啊，是人类第一次在月球的背面留下了人类的足迹。中国这个月球车的车轴的轴印，我觉得确实啊，这不仅是中国人的骄傲，我觉得也是全人类的骄傲。
These images, taken by Chang'e 4, are exceptional. Its rover is thus the first to explore one of the most enigma-rich regions of the entire moon.
月图2号边走边探，还探测了它这个整个行驶过程中的地下的地质剖面图，大概地下300米左右，就是用雷达探测地下。我们现在叫测月雷达，就是它的分层是什么样子。那么分层值，比如它哪一层、哪一个分层、哪个分层在什么深度，你就可以知道月球当年生成或者当年撞击过后经历了什么演变。
More than 50 years after the Apollo missions, this Chinese exploit will give an historic boost to lunar science. Even though, in the laboratories, the researchers have never taken their eyes off the moon. In France, on the heights of the Côte d'Azur, the Plateau de Calerne has seen the proliferation of a number of domes housing numerous observation and measurement instruments. A site sheltered from the light of cities. A green laser splits the sky and points to the moon. Here, we measure the distance between the Earth and the moon to the nearest centimeter, thanks to reflectors placed during the Apollo missions. The data led to a startling discovery. The moon is moving away from Earth by about 3.8 centimeters per year. And this is not the only source of astonishment. Christoph finds planetary scientist and geophysicist Mark Witzerek on site. This researcher from the Observatory of the Côte d'Azur, at the forefront of lunar studies, deconstructs our received ideas.
So, from what we know about the moon today, can we just say it's a dead rock?
There's a lot of people who say that, and I would like to argue that that's not the case at all. With the Apollo missions, we put seismometers on the surface, and just as you measure earthquakes on the Earth, we measure moonquakes on the moon, and we found out that the moon is seismically active.
Okay.
Still today.
Even now?
Even now. Every time the moon goes around the Earth, there's in essence a new moonquake that occurs.
Apart from the moonquakes, is there a real difference between the far side and the near side of the moon?
I would say that's one of the biggest defining features of the moon when you compare it to all the other bodies in our solar system, is that the near side is very different from the far side. And just the first example is that we can see all these lava flows on the near side. They cover about 1/3 of the near side of the moon. But when you look on the far side, there's almost no lava flows at all.
The European Space Agency also has teams trying to unlock the secrets of the moon. Specialist in space exploration management, James Carpenter knows the lunar terrain as if he had walked on it himself.
We're looking here at the moon the way we would see it from Earth normally, right? So it's, and you see these light areas. These light areas are the oldest parts of the moon. They are the first bits of the crust that solidified from what was a magma ocean originally. And then these darker areas are what we call the mare, and these are rocks that have been erupted from beneath the surface and have flooded these areas over the top. And what we see are the landing sites of the Apollo missions are all in this kind of band around here. The samples that came back from Apollo and the research that was done there really completely transformed our understanding of the Earth and the moon and the history of those two bodies, but also gave us the basis for our understanding of how planets everywhere form and the whole history of the solar system.
The more than 380 kilograms of lunar samples brought back during the Apollo missions were an invaluable resource for the progress of science. With the exploration of its far side, the moon is once again at the heart of scientific news. In this dynamic, the Chinese Space Agency wants to take its lunar investigations a step further with Chang'e 5. This time, it's no longer the far side that's targeted, but another highly delicate and complex objective. Not only to collect soil samples in an unexplored region of the visible side, but also to bring them back intact to Earth. To prepare for this perilous mission, the Chinese agency does not hesitate to forge collaborations by joining forces with the best international planetary scientists. One of the most advanced and in demand in her discipline is French researcher Jessica Flau, based in a CNRS laboratory in Nancy.
J'ai été invitée à réfléchir avec les équipes chinoises sur cette zone, cartographier tout ce qu'on pouvait voir, tout ce qui pouvait être un élément d'intérêt pour l'atterrisseur. Donc on a vraiment fait un inventaire de tous les objets intéressants, toutes les roches qui pourraient être intéressantes à ramener dans la zone d'atterrissage de Chang'e 5. La mission s'est très bien passée puisqu'ils ont échantillonné plusieurs kilos de roches, à la fois à l'aide d'une pelle et à l'aide d'un système de forage, et qu'ils ont pu ramener vers la Terre de manière complètement automatisée.
On December 17, 2020, a new historic milestone. The Chang'e 5 mission return capsule lands on the snowy ground of Inner Mongolia. A 3-week mission with no hitches. These are the first lunar soil samples brought back to Earth since 1976. China is the third country, after the USA and Russia, to achieve such an exploit. One of the very first to lay eyes on these new lunar fragments is Professor Li Chunlai of the National Astronomical Observatory. From an impeccable laboratory with the highest high-tech standards, he's in charge of the first analyses.
但是没有样品没拿回来之前，我们心里是打鼓的，不知道的。但很幸运，我们采的样品确实是完全不同于阿波罗的岩石样品。我们长5号采样回来之前，我们根据阿波罗时代美国的样品的研究结果，认为月球的 岩浆活动在30亿年以前结束了，后面没有大规模的岩浆喷发、地质活动，就是它变成了一个僵死的天体，在地质上已经基本上死了。但是嫦娥5号样品回来后，我们发现20亿年还有岩浆喷发，那就说明阿波罗时代的结论是错误的。这是我们最大的一个发现，在20亿年之前，至少是还有玄武岩浆的喷发。
The samples from the Chinese mission offer this first revelation. The moon's volcanism lasted far longer than was believed, 1 billion years longer. In order to push the analyses further, close international cooperation is essential. Jessica Flau's laboratory is one of the best in the world for the study of extraterrestrial soils. It was selected by the Chinese Space Agency to receive part of the samples from Chang'e 5, with perhaps some additional discoveries. Jessica, like the entire scientific community, sees new prospects opening up. Until Chang'e 5, much of what we knew about lunar soils was based on studying the Apollo samples, whether it was the typical lunar seas on the near side or the lands that form the moon's oldest soils.
C'est la première croûte de la Lune. Elle représente à peu près 83% de la surface de la Lune et sont composées d'une roche assez claire qu'on appelle une anorthosite. Alors ça, c'est un exemple terrestre, elle vient de Norvège, mais c'est des roches qui, à la base, sont assez rares sur Terre et qui, au contraire, forment le gros de la surface lunaire. Par comparaison, les mers lunaires, c'est vraiment des plaines volcaniques et c'est une roche qu'on appelle du basalte, qui est très sombre, qu'on trouve par exemple au niveau de la plupart des volcans terrestres et ce qui forme la croûte des fonds marins. Mais il y a aussi ce qu'on peut appeler les terres rares, le lantane, le platine, il y a les métaux sur la Lune, donc ça peut être du titane, de l'aluminium.
The revival of research into the moon is revealing its secrets. For us Earthlings, its soils and subsoils would be full of potential resources.
地上矿物有多少种？地上矿物有4000多种，4000多种。目前我们探测到月球上的矿物有100多种，100多种这里面，据科学家讲，大概有6种矿物是目前地球上没有的新矿物。那么在火星上有多少？探测火星上大概有500多种矿物。
Dozens, hundreds of minerals, some not found on Earth. There's a dizzying amount yet to be discovered. This fuels our desire to explore, not only to the moon, which is close, but even further away. Space agencies now design their programs on the scale of the solar system. And humanity starts to dream of these infinite horizons. And it's mobilizing major resources to reach them. New spaceships, the most massive ever imagined, with the moon as first port of call. The great novelty on the American side is the giant rocket SLS, Space Launch System, the largest launcher built since Apollo. More than 3,000 tons will blast off, propelling a small capsule called Orion towards the moon. SLS and Orion spearhead the Artemis program, NASA's vast new crewed space program.
Orion started as a capsule that was going to get us near the moon. SLS was developed without a destination, although most people, I think, accepted that it would be for the moon first and then hopefully onto Mars. We've spent over $40 billion of the US tax dollars, so we are very close, hopefully, to a test flight. And then within the next year or two, the first humans going past the moon, and then a landing, NASA's now saying 2025.
At this time, I give you a go to resume count and launch Artemis 1.
After years of effort, the Artemis 1 mission was launched on November 16. Even though this first test mission is uncrewed, it's the start of a new space adventure. The European Space Agency, ESA, is actively participating in the Artemis program by providing part of the Orion capsule, but also other essential elements for another impressive part of the project: the construction of a station in orbit around the moon, Gateway Station. Gateway will be the first habitable station outside the Earth's magnetic field. Astronauts will regularly dock there with Orion before going to the moon and back. The first European modules of the Gateway Station are assembled in the Italian Piedmont. On site, Christophe Galfard meets two of its main designers. Modest and discreet, Anna Maria Piras and Franco Fanoglio have nevertheless taken up incredible challenges. Both contributed to building the International Space Station, which has been orbiting the Earth for 2 decades now. True to their primary concern, protecting crews, they're pursuing their childhood dream with Gateway, the very first station around the moon.
We don't want to stop to the moon. When you're kids, you start to look at the moon as your objective. I want to go there. When you are growing up, you start to look at the complete solar system. Its exploration is a new frontier for everyone. If we go from low Earth orbit, on which there is, at this point, a quite consolidated experience, and we move to the lunar orbit, the challenges are changing because of the time to get there. That is clearly much longer. We are talking about a week versus a day. We are also experiencing a relevant level of radiation that are clearly incompatible unless we have the proper protection with respect to the life of people in orbit.
And so, because of the cosmic radiations, how long can an astronaut remain? Do we know?
We can say that roughly they cannot survive more than 1 month, 2 months, or at least they cannot extend out of this time without starting to have some problems to their body, to their internal organs, etc.
Gateway, orbiting the moon, will no longer be shielded by the Earth's magnetic field. Its modules will be the only life insurance for crews against the violence of the space environment. Their structure is therefore reinforced to become the best possible shield against solar and cosmic radiation. Several metal layers are superimposed to form a shell, acting as a bumper, slowing down and breaking up the most dangerous particles. The next, internal layers, made of Kevlar or even water-filled, absorb the rest. Safe thanks to these technologies, humans will soon be back, around and on the moon. Whether in the Gateway Station, the Orion capsule, or future landing craft. The Chinese Space Agency is following another path, preferring to devote itself chiefly to robotic exploration, more economical and cautious. But whatever the option, it's essential to deepen our knowledge of the lunar terrain, its composition, its relief. Drawing up maps of the surface of the moon is a major challenge. Before going, you have to find the ideal site. Be as sure as possible, otherwise the whole mission may be compromised.
嫦娥1号呢是全月的遥感探测，嫦娥2号呢也是一个全月的遥感探测。嫦娥2号呢就实现了对月球的分辨率呢就可以达到7米的全月的一个分辨率的一个能力，也获得了这些信息。另外呢，嫦娥2号也对重点的区域呢进行了这个1米左右分辨率的这个成像的信息获得。
This moon that seemed inaccessible to our ancestors has been mapped with exceptional precision by China. These are high-resolution maps patiently assembled over the missions. Thanks to the Chang'e program, these images of the moon are more accurate than ever before. If we printed them in full resolution, they'd be as big as a football field.
The moon is a very large area, the surface area about the size of Africa, right? So it's a lot of area to explore, a lot of variation, a lot of diversity. So there is a lot of work that goes on identifying where the most interesting places would be to go. At the moment, there is a lot of international focus on the poles of the moon. And the reason for this is that at the poles of the moon, we know that there are areas that are permanently dark and very cold, where we have water ice and other what we call volatile chemistry that is trapped. And so one of the things we need to understand that some of these earlier missions are going to be doing is going to different places within this South Polar region, digging beneath the surface and trying to measure the water ice that we find there and other chemistry that we find. And that would allow us to really understand whether this is a reserve, a resource that can be used or not.
Evaluating the presence of water becomes the priority for this lunar exploration. That's why the next Chinese lunar missions are designed with this goal in mind. Chang'e 7 will head for the lunar South Pole, hoping to confirm the presence of water in the darkness of these craters. But first, Chang'e 6 will face a new challenge. The first sample collection on the far side of the moon.
我们希望一个是人类第一次采集到月球背面样品，第一次希望能够采到来自于很深的样品，甚至月幔的样品。我们希望这一天早日到来。
The Chang'e 6 mission will not be limited to collecting samples. The probe will also carry many measuring instruments, some valuable for the study of lunar water. Researchers around the world are actively working with China to develop such equipment.
我们这次也不是一个项目在搭载，这个是和法国合作的，因为这个我们本来月球探测就是一个和平利用月球的一个科学项目，这科学项目是国际化的，科学无国界，应该说，这个能够大家共同来深化对宇宙的认识。
Hu Hao and the Chinese Space Agency have teamed up with one of the most creative French research centers in the field, the Astrophysics Institute, or IRAP. Pierre-Yves Malin is one of the creators of DORN, a new measurement tool that will go to the far side of the moon aboard Chang'e 6. To invent this type of instrument requires a thorough knowledge of the moon. You want to explore its subtleties, its mysteries too. The original idea that germinated within IRAP was to study a radioactive gas, radon, released from the ground, on Earth as on the moon. Monitoring radon makes it possible to understand the transport of gases in the ground and in the atmosphere of a star. Since Apollo, we know that the moon has an extremely thin atmosphere in which gases migrate. Radon, of course, but also water vapor. These gases seem to accumulate in the coldest regions of the moon, at the poles. DORN's mission is to measure radon, easier to detect than water. Radon is rather like a spy who traces and tracks the presence of water. The instrument is soon ready to go to China, then into space, aboard a Long March 5 rocket. But first, it must suffer and endure various torture sessions under the eyes of its creators.
Le décollage de la fusée Long March 5 représente l'une des phases les plus critiques de la mission, puisque c'est l'étape pendant laquelle l'instrument va subir les plus fortes vibrations. Pour s'assurer que l'instrument de vol va résister à ces vibrations, nous sommes obligés de construire une maquette mécanique que nous avons aujourd'hui vibrée à toutes les fréquences qui nous ont été spécifiées par les Chinois. Et donc notre instrument aujourd'hui a passé avec succès tous ces tests mécaniques. Ensuite, nous ferons subir à l'instrument des tests thermiques pour simuler à la fois les variations de température qu'il va subir pendant la croisière vers la Lune et puis pendant les 48 heures qu'il va passer à la surface de la Lune, où il pourra faire soit très chaud, soit très froid en fonction du choix du site d'atterrissage.
C'est un défi d'aller à la surface de la Lune, hein, pour les conditions extrêmes. C'est encore pire au pôle sud de la Lune. On a très peu d'énergie puisqu'on reçoit moins de lumière du Soleil. On peut atteindre facilement les moins 200 degrés Celsius, hein, au pôle sud de la Lune. Donc il faut des robots qui peuvent survivre à ça. Donc survivre à la pénombre, survivre aux températures extrêmes, être capable d'aller forer. On a plein de problèmes aussi de questions de comment est-ce qu'on va échantillonner, mesurer cette glace, parce que est-ce que quand on va forer dans le sol lunaire, elle ne va pas finalement se volatiliser, partir sous forme de vapeur, et donc est-ce qu'on va pouvoir, est-ce qu'on va pas trop chauffer en forant, et est-ce qu'on va pouvoir vraiment la mesurer? Donc j'ai envie de dire, il faut déjà répondre un petit peu à tous ces défis.
During the Chang'e 3 and 4 missions, the Chinese teams had already had to face the hostile lunar conditions.
比如说我们去的那个地方，中午温度大概是90度，晚上的时候呢是负的190度，就是接近300度的温差。那么一般的这种电子的设备肯定是不行的啊，需要想出来各种各样的一个办法啊，包括散热，包括晚上的时候的保温啊。我们使用了一种呢，就是对着阳光进行散热这样一种的其他的航天器不太用的技术手段解决了这个问题。这个问题的解决，应该说给我留下的这个印象最深刻。
The extreme temperatures, the impassable terrain, all this creates titanic challenges to recover the frozen water hidden at the bottom of the polar craters. In reality, none of our current robots would survive such a descent for long. Why are agencies working on it anyway? Why brave such dangers? You need a very good reason.
On parle beaucoup de ressources lunaires. La ressource majeure lunaire, effectivement, essentiellement au niveau du pôle sud, c'est l'eau. Parce qu'avec l'eau, d'abord, vous faites survivre effectivement des équipages. Ça vous permet de ne pas amener de l'eau parce que chaque kilo est extrêmement cher quand vous voulez l'atterrir sur la Lune. Mais aussi l'eau, si on l'électrolyse, donc si on a de l'énergie pour l'électrolyser, ça fait du carburant, ça fait de l'oxygène et de l'hydrogène. Ce sont des carburants de beaucoup de fusées qu'on fait décoller depuis la Terre. Et décoller depuis la Lune, c'est beaucoup moins énergivore que de faire décoller sur la Terre, puisque la gravité est 6 fois moindre.
So there's a real rush for lunar water coming. This water is proving to be providential for the future of space exploration, for the creation of future inhabited bases, as well as for the journeys to get there. Along the way, it reveals what's in the works, living on the moon. This adds a stage to highly delicate exploration. Training has already begun to make it a reality. Our planet has terrains very similar to lunar landscapes. Isolated sites, often volcanic, are chosen to experience the conditions of life in an extraterrestrial habitat. In the hollow of an old lava flow on the slope of the immense Mauna Loa volcano in Hawaii, the High Seas International Base is one of these simulation sites.
High Seas is one of the few places on
Base manager Michaela Musilova shows Christoph the facilities.
and Mars will be, at least for the first few missions.
She also offers him a field trip that simulates lunar or Martian conditions.
Okay, yeah, so that, yeah. You can put it on, make sure that the straps are good.
It's heavy.
It's pretty heavy, well, it's keeping you alive, yeah.
Yeah, it should be then. Okay. There we go. Like this.
Looking good so far.
Can you check?
Yeah, check, looks like you buckled up. Everything looks good.
Thank you.
Though the site of this earthly volcano offers a geology similar to the moon, its surface conditions are quite unlike the mortal dangers that reign on our neighbor. The level of radiation, the rains of micrometeorites like nails flying at 40,000 kilometers per hour. Protecting bases on the ground is one of the key difficulties of an installation on the moon. In the heart of the lava field, Michaela knows a fascinating place that could inspire future lunar explorers.
All right, welcome to the lava tube.
That's splendid.
So we're gonna go down here, but watch out, this whole terrain is very unstable, gonna be wobbly, so make sure you squat, have your hands ready to hold on to things if necessary, and especially take care descending down here. All right, this is it.
I understand you love this place. It's so beautiful.
It is gorgeous. That's one of the reasons I love my job and I love coming here all the time.
It's funny because to me it's a bit scary.
I mean, I can imagine why people might find it scary, but for me, it means exploration. It means places to go and trying to find life, for example, or even a new home for humans on Mars or the moon one day.
That's amazing.
Michaela and Christoph sink into the volcanic bowels of Hawaii's Big Island. like the repetition of a similar exploration of the lunar basement in search of cavities that could provide habitat for the first colonists of space. If we're preparing to explore the moon from all angles, it is because it could be the key to deep space. It's the best training and departure base to send humans further, in particular to Mars. The red planet is the other major objective of space research. For 20 years now, it has received our exploration robots. The rover on the Chinese Tianwen program has been making its way across Mars since May 2021.
因为有了前面的这样的一个工作，还有一个对于技术的掌握啊，也就是包括整个任务的这样一个成功的实施，确实是增加了我们对于后续任务的信心，确实是这样。比如我们在火星任务中，有了月球前面的环绕着陆巡视，那这样一个技术力，虽然月球跟火星探测有很大的区别啊，在天问1号的时候，我们就通过一次任务实现环绕着陆和巡视。
现在我们就走出去了，通过月球走向深空，这个过程应该说达到了我们航天整体提升能力水平的这么一个目标。
The United States is also on the surface of Mars. NASA's heavy-duty rover Perseverance landed successfully shortly before Zhurong. The space powers are rushing to Mars because the stakes go beyond that of resources. It's to flush out traces of life. A universal quest is underway, the holy grail of interplanetary research. This is why Americans and Europeans are focusing all their technological know-how on Perseverance. Tirelessly, Perseverance surveys a vast crater named Jezero, on the lookout for everything that could have favored life. The crater is home to the remains of a delta. The rock there bears the mark of powerful runoff. Deposits have formed that perhaps hosted life forms in the distant past. Liquid water is the wonder that humanity seeks above all else in the vastness of space. Essential to our survival, but also a possible cradle of life somewhere other than Earth. All the agencies are racing toward this goal on the Moon, Mars, and throughout the solar system. Our expansion in space in search of traces of water and life raises the question of the fragility of extraterrestrial environments. What would happen if we landed without consulting each other, with huge machines and crews? Wouldn't we risk irreparable losses?
我们去别的星球去，都是有这个地外星球保护的这样的一个设计和一个注意这个不去污染这个地外天体的。这个是不管是我们在月球上探测，还是在火星上，都是有这个要求的。我们对所有的探测器都会做一个洁净处理、无尘化处理，还有无菌化处理。不能把地球的生物啊什么之类的带到另外一个星球上去。还有一个就是尽量的减少对它的一个干扰和污染，这是没问题的。
But some big players, especially in the private sector, don't really seem concerned about this kind of risk. SpaceX, a company founded by Silicon Valley billionaire Elon Musk, is pushing an offensive interplanetary program based on a revolutionary launch vehicle, the Starship. Oversized, fully reusable, the Starship revolutionizes standards. Against all odds, NASA chose the Starship as the reusable lunar lander for the Artemis program. What pollution will the comings and goings of such a ship on the Moon or on Mars cause? And how can it refuel in situ and be able to take off again and return to Earth? Do such projects already herald uncontrolled use of extraterrestrial resources? To ensure supplies of machines, bases, and crews, a business plan emerges. Appetites awaken. Space industries can be born and grow, as well as the prospect of colossal profits. This then opens Pandora's box.
In fact, one of the reasons to go is getting heavy industry off of planet Earth, is keeping Earth as somewhere where humanity can continue to live indefinitely, is something that requires space resources ultimately over time. And so being able to start to manage resources and manufacturing with celestial resources, lunar, asteroid, et cetera, is, I think, a very critical part of the whole picture.
The space age that's beginning throws up tricky new questions, especially ethical issues. For the first time in its history, humanity must question its expansion outside its home planet. Will we be able to keep in mind that the treasures of the universe are as precious and fragile as those on Earth?
What is happening now is the early exploration of space resources to understand what is there and how usable it could be. And it's very fragile, and as we start to access these things and use them, we are going to permanently change the environment in which we found them. And so it's important to understand what effects we might have and to work out ways that we can manage those environments in a responsible way so that we preserve them for future generations too. If we, humans, countries, agencies, whoever, want to be participants in what is coming for humanity in space, then I think the Moon is a really important place to be. It's where we're going to learn to live and work off-world. It's where we're going to address the challenges, where we're going to develop the technologies and perform the scientific research that makes everything else possible. If we can cooperate in space, and we can learn how to do that, I think there are lessons that we can bring back to Earth, and I think that will benefit all of us.
A space revolution is well underway. It takes off on the other side of the Moon, our precious ally in furthering exploration of our solar system.
但接下来呢，在行星探测领域呢，也有两个这个关键词，一个就是这个更多的目标啊，第二个就是更远的距离啊。更多的目标呢，就是我们可能不仅仅是火星了，我们可能会下一步还会瞄准着木星啊，这个小行星啊，这个作为我们的一些这个探测的目标啊，这是多目标了。 来使我们这个对于行星探测的触角呢，可以伸得更远一些，这样我们可能能够获得的信息会更多一些。
A new page is being written in our space history book. It will have decisive consequences for the centuries to come. Scientific, economic, and ethical consequences that concern us all. All around the world, scientific research is progressing, and with it, our ability to build new collaboration for the future.